Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. And in this video lecture we will study Gauss backward interpolation formula. So Gauss backward interpolation formula is also a central difference formula and used to interpolate the value in the center of the table. And this formula is useful when value of u lies between 0 and minus 1 by 2. So this formula is useful. So now we'll be deriving Gauss backward interpolation formula, and for Gauss backward formula the value of u lies between 1 by 2 and 0, that is for Gauss forward interpolation formula. Fine, now we'll be doing its proof, and we will be writing Newton forward interpolation formula as done in case of Gauss forward interpolation formula. We know that y is equal to y naught plus u 1 delta y naught plus u2 delta square y naught plus u3 delta cube y naught plus u4 delta 4 y naught. We have written it something like that in Gauss forward interpolation formula, and we have written the same, and I am going to put it as 1, where you will write this u I is equal to u minus 1 u minus 2 up to u minus I minus 1 divided by I factorial. Fine, this is further equal to u minus 1 u minus 2 up to u minus I plus 1 divided by I factorial. Fine, so this is u subscript I, and this is given on this formula. Now here in Gauss forward interpolation formula, you know, we have diminished the subscript of y after first two terms. Now in this we will be doing the same thing, diminishing the subscript of y, but instead of first two terms we will be diminishing the subscript of y after first term. Instead of two term we will be diminishing it right away after first term. So now I will be writing diminishing, so we will need to diminishing the subscript of y by 1 after first term. And for the same we will be using the relation, and relation will be delta n, it will be y naught delta n y minus 1, and by definition you know this is nothing but delta n plus 1 y minus 1. This implies that delta n y naught is equal to delta n plus 1 y minus 1 plus delta n y minus 1, and here n is equal to 1, 2, 3. So here I need to write n 1, 2, 3 and so on. Fine, so we will be using it in equation 1, diminishing the subscript of y by 1 after first term in 1. So using above result in 1, what we'll get, will be getting y is equal to y naught plus u1 and put n is equal to 1. What it will be? Delta square y minus 1 plus delta y minus 1 plus u2 as such. Put n is equal to 2. Delta 3 y minus 1 plus delta 2 y minus 1 plus u3 as such. Put n is equal to 3. Delta 4 y minus 1 plus delta 3 y minus 1 plus put n is equal to 4, 5 and 4. This will be u 4 delta 5 y minus 1 plus delta 4 y minus 1 and so on. So now we will be collecting the terms. This will be y naught plus delta y minus 1 first, u1 plus delta y minus 1. Delta square terms will be collected together, u1 plus u2. This will be delta square y minus 1. Delta cube terms, this term and this term will be collected, and this will be u2, u3, and outside will be delta 4 term will be collected, u3, u4, and outside we have delta 4 y minus 1, and delta 5 will have the combination in the following term, so we don't need to write it and we will do generalization. So by previous formula used in the Gauss forward interpolation, the same formula will be having this is u plus 1 and the greater subscript 2, we know the result, delta square. So I don't need to prove it again because we had done it in the previous article, that is in the proof of Gauss forward interpolation formula. This will be u plus 1 3 delta q minus 1 y minus 1 plus u plus 1 4 delta 4 y minus 1 and so on. And you could also mention the result u subscript I minus 1 is equal to u plus 1 subscript I, and here I is running from 1, I is running from 2. When you will put 2, it will be 1. So I is running from 2, 3, 4 and so on. Fine. So now you see the pattern. U is increased by 1, subscript of y remains the same. Now u plus 1, this remains the same. Subscript of y is again the same. But here, because this is increased, so this remains the same, is justified. But this remains the same, u plus 1 remains the same. This should decrease. So here instead of y minus 1, here should be y minus 2. So we need to diminish again the subscript of y after how many terms? 1, 2 and 3. After 3 terms we will be diminishing the subscript of y. So once again I am going to write diminishing one decreasing, diminishing the subscript of y, and you may name it as equation number 2. subscript of y into by 1 after first 3 terms. Okay, fine. So we will be doing this after first 3 terms. So here subscript is -1, we need to take it to -2. So the formula for this will be delta n y minus 1 minus delta n y minus 2. This will be delta n plus 1 y minus 2. This implies that delta n y minus 1, this will go over there, delta n plus 1 y minus 2 plus delta n y minus 2. And here, since we are using it after 3 terms 1, 2 and 3, so here n is equal to 3. So here n is equal to 3, 4, 5 and so on. Using the result in equation 2 after first 3 terms, we get so what it will be, y is equal to y naught, and this will be same u1 delta y minus 1, this will be the same u plus 1 subscript 2 delta square y minus 1 u plus 1 subscript 3, and now use this one, n is equal to 3, this will be delta 4 y minus 2 plus delta 3 y minus 2 plus u plus 1 4, use it for n is equal to 4, delta 5 y minus 2 plus delta 4 y minus 2 up to so on. This is further equal to y naught plus u1 delta y minus 1 plus u plus 1 subscript 2 delta square y minus 1, and this is the single term, so I am going to write it u plus 1 3 delta 3 y minus 2 plus this, and this will be written as u plus 1 3 plus u plus 1 subscript 4, and outside is delta 4 y minus 2, and taking the other terms in the generalization. So this is further equal to y naught plus u1 delta y subscript minus 1 u plus 1 subscript 2 delta square subscript minus 1 u plus 1 subscript 3 delta cube y subscript minus 2, and this will be u plus 1 u plus 1, so formula will be u plus 2 1 more and greater of the subscript, it will be 4, so this will be delta 4 y minus 2 up to so on. Now look over the pattern, u to u plus 1 increase, this should remain the same, it is remaining the same, u plus 1 remaining the same, this should diminish by 1, subscript of y is diminishing by 1, this is being increased with 1, so this should remain the same, it is remaining the same, and continuing likewise. If we will write the next term of this series, we will need to diminish further, so we will continue this process, and this result is nothing but the Gauss backward interpolation formula Fine. And this formula used when u is between -1/2 and 0. So this formula is a Gauss backward interpolation formula, and I hope you will be able to understand and grasp the idea in this Gauss backward interpolation formula, which is a central difference formula, and this is used when u is between -1/2 and 0. So that is all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.